Learning outcome 8.2, equilibrium of a uniform rigid body. We're going to define torque, and solving problems will be done in your tutorial. Okay, equilibrium of a uniform rigid body, we're going to look at torque, which is moment of a force. So here, torque is the tendency of a force to cause or change rotational motion of a body. Okay, so it is tendency for a rotational motion. Torque, also known as turning effects of the force. Okay. Torque is defined as the vector product between lever arm. So you have torque equals to R cross F. So cross F indicates your torque is a vector product. So for cross product, when you expand the equation R cross F, it will be RF sine theta. Or when you rearrange, it can be expressed in terms of FR sine theta, where your R sine theta can also be written as D, where tau is the magnitude of the torque, F is magnitude of force, R is magnitude of lever arm, where this one basically is the distance from your pivot to force applied. So when you apply force here, this will be your R, distance from pivot to force applied. D, R sine theta, where D is the perpendicular distance. Theta is angle between R and F. Torque equals to Fd, where the magnitude of the torque is defined as the product of force and its perpendicular distance from the line of action of the force to the point. We're going to look at different cases of torque later. Torque is a vector quantity, and based on the formula of torque equals to Fd, so force is Newton, then D is meter, so you will have Newton meter as unit for your torque. How to determine the direction of torque? You can determine the direction using right hand grip rule. First, you're going to point your fingers to the direction of R. So, let's say if we take this example here, you're going to point your fingers upward, following the direction of your R upwards. Then you will curl your fingers towards F. Now we applied force roughly into the page. So your fingers upward, then you curl into the page. Your thumb points to the direction of your torque. So you can see that your thumb directed to the left. R upwards, curl into the page, your force, then your thumb will be to the left. Okay, sign convention of torque. When your rotation is anti-clockwise, so when rotation is anti-clockwise, so you will have a positive torque. Then if the rotation is clockwise, you will have a negative torque. Magnitude of torque depends on how much force is applied. So your torque variable that influence your torque is force and D. Basically, force and length of your lever arm is directly proportional. Increase F, torque increase. Or when you increase the distance between your pivot, so this is where your pivot is, pivot to the force applied, basically it will increase torque. When you move the force closer to the turning point, to the pivot, this is less torque. Okay, case 1. A force is applied perpendicular to a meter rule, which is pivoted at one end. So this is where your pivot is. So pivoted here. Then you apply force 90 degree to your R. So based on the formula given, FR sine theta, sine 90 degree is equals to 1. So you will have a maximum torque. Now, how to determine the sign convention? Okay, you have to imagine when you pivot at one point, then you apply force here. Now this meter rule will rotate anti-clockwise. When you apply force upward, so it will rotate anti-clockwise. Anti-clockwise is a positive torque. So you have to put your positive here. Okay. Case 2. A force is applied at an angle 60 degrees above x-axis to a meter rule which is pivoted at one end. So pivot. Now your force is 60 degrees above x-axis. Fr sin theta. Determine the direction. Okay, is it clockwise or anti-clockwise? Now pivot, force. When you apply force, your meter rule will rotate anti-clockwise. So for anti-clockwise, this is a positive torque. So direction, you have to determine whether it is a positive torque or a negative torque. Clockwise negative, anti-clockwise positive. Then substitute what is your angle between your F and R. You can use either 60 degree. So this is your R, 60 degree, or you can use 120 degree. Both will give you same answer. Case 3, below x-axis. Okay, 60 degree below x-axis. Fr sin theta, determine direction. Force to pivot. So this meter rule will rotate clockwise. A clockwise will give you a negative torque. So you have negative Fr sin 60 degree or negative Fr sin 120 degree. Equilibrium of a uniform rigid body. Rigid body is defined as a body with the definite shape that doesn't change. So the particles that compose it stay in fixed position relative to one another even though a force is exerted. Okay, doesn't change. Rigid body, even force exerted, it doesn't change shape. If the rigid body is in equilibrium, means the translational and the rotational is equilibrium. What does it mean by translational and rotational? First, the vector sum of all external forces must be 0. So your translational is the linear in x and y component, in x and y. And the vector sum of all external torques acting on a rigid body must be 0. Next is your rotational. So your rotational is your torque equals to 0. Example here, as you can see, your force FA, FB, equilibrium with M1G and M2G. So downward force balance up upward force, and okay, now here is considered as pivot. So this lorry here, this bridge will produce counterclockwise torques. Then this one here, the normal from this one, okay, the normal will contribute to a clockwise torque. So from here, your counterclockwise equals to clockwise torque, which means translational in equilibrium, rotational is in equilibrium. Okay, all the calculations about torque, equilibrium will be done in your tutorial session. Thank you.